Hey guys, so we will actually finish the last part of lecture 3. It's a very small, going to be a very small video, but I just want to quickly repeat the bond one more time, the three types of bond we discussed, and then we'll get into that. Use this video when you are studying for exam, and also watch this video and listen to this video before you come to class on Wednesday. So the last thing we discussed is the three types of bond this Friday. So the first type of bond is ionic bond, where there is a positive and a negative ion, and there is an electrical attraction between the two. The positive ion is called an electron donor or cation. The negative ion is called as electron acceptor or anion. For example, sodium and chlorine. So sodium is a cation and it has only one electron, but because it is a cation, it will donate the electron. Chlorine is an anion. It's an electron acceptor, so chlorine will accept it and then it will form a new compound called sodium chloride. All right, so that's ionic bond, attraction between a positive and a negative charge. Covalent bond, also they share electrons, but here it's not a complete transfer. They simply share electron and form either polar or non-polar structures. So polar means there will be two poles, a negative and a positive pole, and non-polar means there will be no pole and no difference. Typically, non-polar covalent bond happens between atoms with same electronegativity. So therefore, there is no difference in charge. So there is no pole. As opposed to that, polar will have two different electronegativities, one negative, one positive. So there will be a pole. For example, suppose carbon dioxide. In carbon dioxide, these are similar molecules, carbon similar elements, carbon and oxygen. Though they simply share the electron and form polar non-polar covalent bond. So there is no pole, it's simple linear molecule like you see here. But in case of water, suppose, so that's not the case. They will still share the electron and form a covalent bond, but since there is a negative ion which is oxygen and there is a positive ion which is the hydrogen, which is a cation and an ion, again positive ion is the cation, negative ion is the anion, so they will be still sharing electron, but there will be two poles. So for example, here this is pole number 1, the negative one, and the pole number 2. So this is the polar covalent bond. All right, so therefore in ionic bond there is complete transfer of electron. In non-polar that is not the case, there is just sharing of electron. In case of polar, because there are poles, so that's unequal sharing, the charge is still unbalanced. In non-polar covalent bond there is equal sharing of electrons, so there is no pole and the charge is balanced. All right, the third type is the hydrogen bond. This is not as same as the ionic bond though, although there are charge differences, like one is the negative and one is the positive ion. So this kind of bond happens between molecules. For example, suppose water molecule. So the water, each of water molecule, they themselves within them, they will still have covalent polar bond. Like this molecule has covalent polar bond in it, this one has this one, this one, this one. But when it comes to relationship among them, then they will form a hydrogen bond. Right, but the similarity here with ionic bond here is that the hydrogen bond that they are forming, one of the ion of one molecule will be negative and the other ion of the next molecule will be positive. So there is still difference in electronegativity. I mean, it's between molecules, but one end of that bonding will be with the positive ion of one molecule. The other pole or the other end of that bond will be the negative ion. Right, so two molecules, molecule 1, molecule 2, right, but here it will use its negative ion and here it will use its positive ion to really form the bond. Okay, so that is a weak hydrogen bond. So this is pretty important when it comes to water surface tension, Turgor pressure, thermal properties, and we will talk about that later in the chapter. So this is between weak bond between molecules, and there is a difference in electronegativity here. Now the main thing that we'll discuss in this short video is a chemical reaction. There are three types: synthesis, decomposition, and exchange. So what is chemical reaction? Something is reacting to produce something. For example, A and B, suppose these will be called as a reactant because they are the one that is reacting in the mixture, in the chemical reaction, and then it is forming C. So A and B will be the reactant and C will be the product. Okay, so C will be the product. Types: synthesis, decomposition, and exchange. So synthesis means it is still producing something. For example, suppose glucose and glucose, it is producing a new molecule called maltose. If when different amino acid molecules join, they can form a big molecule of protein. So you're producing something new, right? That's what is called synthesis. But oftentimes in biochemical reaction, when we are synthesizing something, we lose a water molecule. That's why it is also called, it can be also called as dehydration synthesis. Dehydration means losing water, right? But the exactly opposite thing of that is decomposition, and especially hydrolysis decomposition. So what happens here the water molecule becomes a product, the water is lost, it's not part of the reaction. But here water is included in the reaction, it is not lost. For example, decomposition first of all means splitting up something, and when it becomes hydrolysis type of decomposition, then water is also split up. So decomposition means, so you AB is the reactant and then water is also part of the reaction, right? So both will split up because this is decomposition and then hydrolysis type of decomposition, so water will also split up. So when we are splitting up water means we are actually getting hydrogen, right, and H2O, so one hydrogen and one OH. So when you're splitting this up, first of all, when you're decomposing AB, then we are getting A and B. You're separating it out. A will get the hydrogen part and B will get the OH part. So water is also hydrolyzed, or that's also decomposed, which is all because the what you're lysing the water, decomposing the water, that's called as hydrolysis. Okay, so that is basically, this is called as decomposition. Example is hydrolysis. For example, you take a huge glycogen molecule, you break it up and form glucose. You will also do lots of hydrolysis in this process. Let's see an example. Suppose you have two monomer 1, monomer 2. You're trying to first of all trying to create something new, so that will be synthesis. But if it's a dehydration synthesis, then you will lose water. So one of the monomer has, each of these monomer has OH and OH, and because this is a dehydration, so this water part H2O will be lost, and what will be left with monomer 1 and monomer 2, and this oxygen will still be there, so that will be linked by a covalent bond. So we are creating something new, but this is a dehydration, so we are losing a water molecule. Suppose we want to now break up this particular structure into as it was before, right? So now we will do decomposition, and this is a hydrolysis type of decomposition. So we will now split up this monomer, and in decomposition hydrolysis water is included, so water will be there. So water will be split into H and OH. So then these two is there. So now one of the monomer will get the H, one of the monomer will get the OH. So they are now split up. So monomer itself, this particular the new product that we created before, one monomer by linking monomer 1 and 2, now this is again splitted into monomer 1 and monomer 2. Like we are completely separating up this molecule, we're decomposing it, but also water is also hydrolyzed, and one of the monomer is getting the H, the second monomer is getting the OH. Another example here, so you have glucose and fructose, they're combining, and now we are trying to, if they produce something brand new like sucrose, that's synthesis, but in the process they will also lose a water molecule. So that this part is basically the dehydration synthesis. Okay, now if I want to split up the sucrose and go back to its original form, then I'm going to do decomposition and hydrolysis, right? So here means hydrolysis. So basically simply means, first of all, I'm going to split up sucrose into glucose and fructose, as well as water is consumed, and water is also now split up the same way, hydrogen and OH. So one of them will get the hydrogen, fructose will get the hydrogen, suppose, and the glucose will get the OH. So I'm not only decomposing sucrose, but I'm also breaking up water, and water is now included in that reaction. So this part is the decomposition hydrolysis. The third type of chemical reaction is called exchange, where we simply exchange between molecule parts. Suppose A, B and C, they react with each other, it can become AC and B. AB and CD, it can become AD and CB. Simply we're just exchanging the molecule parts. Here synthesis and decomposition both is part of the reaction. The fourth type, don't have to go to too much details in this, is called oxidation reduction. Oxidation simply means oxygen is added in that, and reduction means oxygen is reduced. Okay, so oxygen reduction. So for example, when it happens together within the same reaction, that is called as redox reaction. Example, photosynthesis. So oxygen is also added in photosynthesis as well as it is reduced, so that's what is called redox. So these are the three types: synthesis, hydrolysis or decomposition, and then exchange. And the fourth type is also redox. Now, a characteristic of chemical reaction that it is reversible, means it can go in either direction. So you take HNO2, suppose, you can either split it up, like here you can like decompose it into H plus or NO2, or it can again combine or synthesize to form HNO2. So which means H and NO2 can combine and again form HNO2. So reaction can go in either way. Some reactions release energy, for example respiration, like when we respire we release energy, and these are called exergonic, you are exiting the energy. Some reactions absorb energy, these are called endergonic, taking the energy inside. For example, photosynthesis, what kind of energy it absorbs? It absorbs sun energy. Okay, last thing is the factors that can influence chemical reactions. For example, temperature. No matter what, remember, if you apply heat, the reaction will become faster. All right, so temperature always impacts chemical reactions positively. Concentration, if you have more material concentrated, then more will be the reaction size. In terms of size of the molecule, if the molecule is smaller, because they are smaller in size, then the reaction will be more. Okay, they will basically react faster, not more, they will react faster, because their size is small, their mass is less, so they can actually run around easily and they will react fast. But if you have large molecules like this, because they are large in size, so it will take time for them to run around, and therefore it will react slowly. Their reaction will be slightly slower. What are catalysts? Catalysts is something, they are part of the reaction but they don't themselves change. For example, and we will talk about that again later in the chapter. So suppose you have A and B and you are producing C and D. Okay, and suppose this, in general the reaction was taking 5 minutes, and you add E into this, then the reaction can be done in 1 minute. So it is making the reaction more efficient, but at the end of the reaction E will stay as E. AB can become CD, but E will still stay as E. So they themselves don't change. So these are called as catalysts, or also enzymes sometimes. All right, so temperature affects reaction positively. More concentrated you have the substance, more will be the reactant. It's proportional. If you have a smaller particle, they will react more with each other, so the reaction rate will be faster. If you have a larger particle, naturally it will take time to run around and the reaction will be slower. Catalysts, they themselves don't change. All right, so please listen to this video before you come to class on Wednesday. We will do a small revision exercise with these chemical reactions, and then we'll get into next part of this chapter. Okay, see you on Wednesday. Please listen to the video before Wednesday.